Okay, so September paper 1, right? Just now we discussed. Okay. Open up this. Yeah, this paper just now we discussed, right? Let me check. Am I recording? Oh, sorry, not this one. It was. So, do you have any questions still in this paper?
18.
Oh, 18. Okay, good. So we go to 18. Okay, question 18. Okay, the others who haven't tried, give a try. Whenever you see inclined surface, the formula must come to your mind is what? Work done by the thrust is equals to gain in EP, gain in EK plus heat. This formula must come to your mind. Okay, so what the question one? The car 500 rest at point X on slope. The car brakes are released and the car rolls down the slope with engine off. Oh, engine off. If engine is off means what is zero? The work done by the thrust become zero. So no thrust lah. No thrust. Okay. Says point Y, the car has moved through a vertical height of 30 meter or go down by 30 meter and has a speed of 11 meter per second. Oh, here it becomes 11. Here speed is zero. So that means it has gained kinetic. Kinetic has been gained. What is the energy dissipated frictional force when the car moves from X to Y? So the question asking what is the heat? Oh no. Yeah. Energy dissipated by frictional force is actually heat. They're asking for heat. Heat is what? What is heat? So we put the heat as X lah. So X, we are looking for this X. Okay, if you know these two, we can find the X one. What is the gain in kinetic energy? Of M V squared minus U squared. Is your gain in kinetic energy. So what? Half 500 times B is what? 11 squared minus 0 lah, 0 squared minus plus X. And what is the gain in potential? Here no gain potential. Here lose potential. So gain in potential is the MGH, but must put negative because it's lost, drops, lost. The formula is gain, but gain is negative lah. So negative 500 times 9.81 times the H. No, H is what? How much drop? 30. So find your X. X actually the gain in kinetic minus the potential. So what's the answer you got? Gain in kinetic minus the potential. So
1.2 times 10 power 5.
So A lah. What's the answer given? A.
A. I miss out the negative.
Yeah. So because gain, right? The formula is all gain. Right? Potential is negative. Good. Any other question?
Teacher, question 19.
Okay, 19. What's the others comment? Give a try. One minute, take time, try to understand. This is also work. A wind turbine as a blade that sweeps the area of this. It's your area. It converts the power available in the wind to electrical power with efficiency of 60%. What is the electrical power generated if the wind speed is 10 meters per second? Okay. So you have a turbine. Okay, I put like this. You have a turbine. Okay. It's a generator. Okay. So the wind is flowing. The wind has a speed of 10 meters per second. Then it tend to become electrical energy. Energy is electric. Okay. What energy change to what energy? Kinetic change to electric. Okay. But this turbine has an efficiency of 60%. Means what? Efficiency means what? Efficiency is output. I go for energy for this scale. Output energy over input energy times 100% is efficiency. We can go output over input power. But yeah, I think energy better because all are energy. Okay, so efficiency is output over input times 100%. Okay, now. So what is efficiencies for this case? So I write this formula here. So efficiency is how much? 60% goes to, what is the output energy? Who's the output energy here? What is the electrical power generated? Oh, sorry, because they want electrical power. Sorry, then we can't go for energy. You have to go for output power, input power. Okay. Okay, so now, what is the electrical power generated? This electrical power, output or input? Okay, guys, I need your feedback.
Which
The
one?
electrical power, output or input?
Input.
The electrical power is the output, right?
Yes.
So electrical power is output. So you are looking for
Okay.
output. You are looking for the output. Output is the electrical power. Input is what?
10
Input is
meter per second.
yeah, the kinetic energy over the time, right? Because kinetic energy over time is the input power, Okay. Times 100%. This is the formula. Okay. So, okay, let me go to the whiteboard. I can do here. Okay. So the thing is, sorry guys, sorry. So the thing is, right here, 60% equals to output over input kinetic energy is half mv squared over the time times 100%. So 60% output over half m is what? Oh my god, here we got a big trap. M you don't know. But what given?
Density of air.
Density of air and area given. So can you find the mass? Oh, this is trap.
Of air swept.
Yeah, rho times volume, right? V squared over T. Correct? Rho you know, but volume you don't know. So how to change the volume? half. What is your rho? Rho is rho. Okay. Volume is area times the length, V squared over T, right? Length is the, if you have a turbine here, the length is the distance traveled by the wind, the length. The area is the area, 2000 of the blade, and the length is the distance traveled by the air. These are the volume of the air which has been transferred times 100%. You know rho, you know A, but you don't know the length. You know the V. But length over T is what? Length over T is
Velocity.
what? Length over T is velocity. So what happened to the equation? 60% goes to V naught. Yeah. So it's become half rho
V
A
cube.
V cube. Become like this. So from here you can find P naught. So you know the density, you know the area, you know the speed, you know the, yeah, you can find the power output. Very hidden information. Yeah. You got an idea?
Yes.
Of that question. Okay, so L over T become V. We go to the next question. Okay, so that's your question 19. So what's the answer you got? Then you can get the answer.
Hold on, teacher. I'm calculating.
Rho from the question. Rho A V cube. Yeah. So speed we know is 10 squared, 10 cube. A we know just now the A and the rho. You get the answer. Output power.
780 kilowatt.
Okay. Answer given is A.
Yes, the answer is A.
Okay, students, any other question?
So 29.
29, okay, 29. Oh, 29. Okay, guys, this is also very interesting question. Okay, electric field. Recall back your electric field. E equals to F over Q, V over D. Force per unit charge, voltage divided by the plate separation. Yeah. So a small charge sphere of 0.8 gram. This is 0.8 gram. 0.8 gram hangs from a light thread inside a vertical electric field, strength of 2000. Okay. So this is your E. This is your E. Okay, you got the E. The thread passes over the two frictional pulley, and the mass is 2 gram of mass. This nothing. This trying to confuse you, this pulley system. Actually, what is that? The force acting up. How much is the weight of this mass? It's mg. 0.002 times 9.81, right? 9.81 Newton is the force acting up, trying to pull up. So the sphere is in equilibrium. The sphere is found to be equilibrium. What is the charge on the sphere? Okay, they're asking what is the charge on the sphere. Okay, to find the charge on the sphere, you need to find what are the force acting down, what force acting up. What force acting down? 0.8 gram weight, which is 0.8 times 10 power of negative 3 changed to kilogram times 9.81. This is the force acting down. Force acting up is the, what do you call, the weight, the weight of the 2 gram. Now tell me, the sphere charge must exert force down or up? Without the charge, you tell me force up greater or force down greater?
Force up.
Force up is greater, you know. That means the charge, the electrostatic force, right, must act down or up?
Down.
Make it force acting down. So the force due to electric is acting down to be make it in equilibrium. So therefore, the electric force plus the weight of the 0.8 gram should be equals to the weight of the 2 gram. So this is the, what do you call, conclusion lah. So you want charge, what? You want to find the charge. Okay, you want to find the charge. So the Fe you can convert to charge lah. How to write in terms of charge? Q times E, what? QE. E equals to F over Q. So F is QE. QE. Gas equals to weight of 2 gram minus weight of 0.8 gram divided by the E. E. Yeah, you can get the charge. The charge is going to be positive or negative. That's the track. Positive or negative, the Q. The Q going to be, the electric force is downwards. That means down plate is negative. So the charge should be positive or negative?
Positive.
Charge must be positive. Yes, it should be positive. So answer should be either, cannot be A. It should be B, C, D. So weight of 2 gram minus weight of 0.8 gram divided by the E. E is 2000. Get the charge. The charge positive 5.9. I don't know. I think it's going to be 5.9 because they make it more trickier. Positive 5.9 given, negative 5.9 given. I think the answer should be C now.
Yes, teacher.
So yeah. You understand? So hope you can understand. So remember, the electric force not always acting up. It could be down. Check the question. This is one pass here. Okay, any other question?
36.
Class, can we go for 36? Okay, the others, come on, give a try. It's a circuit current. Force statement about either potential difference or electromotive force are listed. So which statement applies for potential difference, which applies for electromotive force? Okay. If you remember the definition of both, I think you can get the answer. What is definition of potential difference? Anyone? The amount of electrical convert to other form or other form convert to electrical. Potential difference. Potential difference is electrical converted to other form. And one column of charge pass through the circuit from one point to another. At a light bulb, potential difference. A light bulb, what happened? Electric converted to other form. Light. Electromotive force is what? Definition. It happens in the battery. What energy change to what energy? The other form, the chemical, change to electrical energy. when one column of charge complete the circuit. That's its electromotive force. Yeah. So it involves changing electrical energy into other form. This is your PD, potential difference law. Electrical to other form is PD. Involves changing other to electrical is your EMF law. The energy per unit charge to move unit around a complete circuit. Complete circuit is EMF. The work done per unit charge moving from one point to another is your PD. PD is one point to another, a part of the circuit. EMF must be complete circuit. So yeah, so 1 and 4 is PD. So B.
Oh, teacher, can you explain the second one again?
Second one. Second one, it involves changing other form of energy into electrical energy. And battery. In the battery, the amount of chemical energy converted to electrical energy. Per unit charge. Per unit charge is your EMF. Let's say EMF given 1.5 volt. Means 1.5 joule of chemical energy, okay, as converted to electrical per unit charge flow. One column of charge when comes up. When one column of charge comes up on the battery, 1.5 joule of chemical energy has been converted to electrical. That is EMF. Okay, involves changing from other form to electrical. Okay.
Okay, thank you, teacher.
Okay. Any other questions? Yes. Okay. Any questions? No other questions.
Oh, teacher,
Okay. Yeah.
there's a question. I'm not sure if it's 33 or 32, talking about a metallic conductor one. I'm not sure. 33.
Okay. 33. Yeah.
Is it
Which
metallic conductor the same as ohmic conductor, or is it different?
metallic conductor is a solid conductor, a good conductor, which obeys Ohm's law. So answer is A. Or could be A or D. What? It's given by the gradient of the gradient of the which. So we where the resistance of the conductor is given by the gradient of the graph. So answer is A lah. A. Yeah. So metallic conductor is like you can avoid a metallic. It's a metal conductor lah. Metal conductor. Metal conductors obeys Ohm's law.
Okay.
B for what? B for the light bulb, and C for thermistor. Thermistor not really in some bulb line. Any other question?
Oh, teacher, if it's ohmic conductor, then which one is the graph?
Ohmic conductor means it obeys Ohm's law. So A and D is ohmic conductor.
Oh, so it's the same as metallic conductor.
What is meant by ohmic conductor? Ohmic
It obeys
conductor
Ohm's
means
law.
Ohm's law. Conductor obeys Ohm's law, therefore they call it also ohmic conductor. Ohmic conductor means the VI graph must be a straight line pass through origin. That is ohmic conductor.
Okay. But when the voltage increase, doesn't the current decrease because the resistance in the wire increases because the heating of the wire?
Yeah, if the temperature, that's why what you can here define ohmic law. Ohmic law is V is directly proportional to I as long as temperature kept constant. If temperature, the graph going to be straight line. V versus I, we must make sure the resistance temperature never rises. As long as the temperature never rises constant, then you're going to take a V straight line graph. But in reality, the temperature is going to go up. If temperature go up, the graph going to curve up. So at a constant, there is a conditional abuse. I is only proportional if current is if the temperature is constant. If temperature constant, then it's Ohm conductor. But practically, we can't show that because temperature will rise practically. But they are Ohm conductor. If you do experiment with never rise the temperature, the VI graph going to be a straight line. Okay.
Okay.
Any other question? Question? Okay. So if you don't have question, we go to the next paper. So next paper is paper 2. Anyone tried the paper 2 here? I go for paper 1. The next one, yeah. August 18. Okay, paper 1. Sorry. Let me close this. Okay, anyone tried this paper?
So I haven't tried this paper yet.
Oh, nobody have tried, Okay. So let me select some question from this paper. We try together. Okay. So let me select the questions. The one I feel could be challenging. Yep. It's easy. Okay. Question 9. 1 minute for everyone. What is the answer for 9? Give a try. Divided with velocity 2u. From a point of P. Ignoring air resistance, find the change in the magnitude of momentum from point P to point Q. Find the changes in momentum. Changes in momentum, vector addition or vector subtraction? You
Subtraction.
add the vector or you minus the vector?
Minus.
Minus, right? Subtraction. Changes. Final vector minus the initial vector is the changes. So V is 2u. Okay, you can WhatsApp me your answer, or you can mention here if you want. Up to you.
Is it 0?
0. So there is no change. You see the initial vector is this one. So this one is 2u. Okay. Okay, 2u. And landing also is going to be 2u. Angle you're going to make is 45. So they want momentum, momentum. Momentum means times with the mass lah. So the initial momentum is what? Then 2 mu. Final momentum is what? Also going to be 2 mu. They want changes in momentum. Changes is what? Final minus initial momentum. So final plus the initial momentum. So draw the final momentum at the tip, join the negative of the initial momentum. And then you find the changes. So where's your final momentum? Final momentum, the vector diagram is going down with 2 mu. Makes an angle of how much? 45. Then the tip here, negative of the initial going up, negative of the initial going down. The 2 mu. So this is your changes. Here is 45. So here also will be 45. So it makes a 90 degrees here. So what is your changes? This is your changes in momentum. So use your Pythagoras. So what's the answer? Changes of momentum is 2 mu squared, all of them squared, plus 2 mu squared, all of them squared. Finally, you get what? 2 mu squared, 2 mu squared, 4, 4. So you get, let me do on top here. I do here. Yeah. Okay. You get what? So rho will be, get 8 m squared u squared. Square, sorry, and this is also square. So changes of momentum is root of 8 is how much? This is tricky. Root of 8, which one? 2 root 2 mu. Root of 8, it's actually 2 root 2. Answer is C. You agree? Root 8 can be written as root of 4 times 2. Then 4 you take out, it's actually root 4 root 2. Root 4 is 2 root 2. 2 root 2 is root 8. So 2 root 2 mu so answer is C. Okay, so remember, whenever go for changes of momentum, it's a vector subtraction. You need to minus the vector. The final minus initial. So final plus negative of initial. Negative initial vector, you have to change direction. And beginning to the end is your changes in momentum.
Answer.
Yeah.
Can we use like the vertical horizontal component way?
Vertical horizontal you can, but easy for resultant. Resultant vector addition can.
You can use the vector triangle to do this.
Yeah, vector addition you can. Vector subtraction also can, but a little tricky. Vector addition, yes, can. I think vector subtraction can be trickier. You need to try to adapt this method. Final minus initial. Because sometimes in exam, they'll ask you to draw this diagram. The Cambridge will ask you to draw this vector diagram. So you have to know how to draw. Okay. So vector subtraction. Check from the video for the vector subtraction. When we do vector subtraction towards the end, I teach you. Try to recall back. You can do this. Okay, any questions, guys, from here? Can you understand?
Yes.
You go to the next one, another one. Oh, I don't know what happened. So I think. Okay. Next one is the question 6. Question 6. 1 minute for you. Come on, give a try. So you can text me your answer, or you can tell me here itself. What is the uncertainty in the height of the pyramid? Length, width, height is given by that formula. The volume is 12% uncertain. The length and base is 4%, or length and base. Length and base. Base length, okay. While the base length and the base width are measured in 4%. Uncertainty in 4%. What is the uncertainty of the height? Yeah.
For
Is it C?
We go for C. So they want the height. Yeah, they want the height. So yeah. So it changes. What is that? Oh my god. Okay. Yeah. So V equals to changes of V over V equals what? Changes of L over L plus changes of W over W plus changes of H over H. Yeah. So they're asking for the H. We are looking for H. Yes, this is 12%. This is 4%. This is 4%. So this is how much? So you get C, 4%. Easy. Okay, good. So all of you got C. Say C. Okay. 7. Okay, spend 2 minutes. Give me the answer. The maximum deceleration is 7.5 meter per second square. While driving at a constant speed, 21 meter per second. The driver sees a stationary car 30 meters ahead. This is like a real life application. So in front, the 30 meter ahead, you have a car. And of course, we do have reaction time. Reaction time was 0.4 seconds. So your brain tells press the brake, but you take 0.4 seconds to press the brake. During that duration, you are still moving with 21 meter per second. Then only the brake applied and it start to decelerate. Determine the speed at which the car will hit the stationary car. So the car, okay, so anyone got the answer? So you have two region, First, it move with a constant speed. The next one only it start to decelerate. So you need to find the distance when you start to apply the brake. Okay, I don't know. You can see the question. Okay, so the car is here. Okay. So without applying brake, maybe another car is here. From here to here is 30 meter. You only press the brake after 0.4 second. During that 0.4 second, is traveling with constant speed of 21 meter per second. Then only when the car is here, then A was deceleration happened at negative 7.5. And the U we know is 21. And the V we know becomes 0. We are looking for the V. V. But to find the V, if you use kinematic, you know A, you know U, you're looking for V, you need another one information. One information I think is best is the S line. You should know this distance. So how do you find this distance first? Then you can find the V. How do you get this distance? To get this distance, you need to get the distance earlier. Distance is move with a constant speed. What is the distance you travel with constant speed? 21 times 0.4, right? The distance traveled here is 21 times 0.4. That's the distance. How much you get? 8.4 meter, I think. So this distance, this S should be 30 minus 8.4. So you get how much? 21.6. So this is your S. So you know S, you know A, negative 7.5, you know U, 21, you can find the V. So how do you get the V? Of course, the formula without T, so use V squared equals to U squared plus 2AS, you're able to get the V meter per second. Oh, sorry. So guys, get the idea? Sorry. So what's the answer you got? Anyone?
Is it A?
So 3 meter per second. Are you use this working? Do you find the distance first? 8.4 meter. Then you minus, you got 21.6.
Oh, I use another working.
Another working. What's your working?
I find the time before it hit the car, and then I minus off the reaction time, and then I use the time to find the final velocity.
Okay, let me check. This is which paper we are using. Just now we used this paper, August 18. See the answer. Just now this is what number?
Number 7.
7 given is C. So 7 is looks like C, 10.8. Should be 10.8. 10.8. You try with this method. Okay.
Okay.
Okay, so this is how it should be done. Okay, I want you to try more questions lah. Tomorrow is Wednesday. Tomorrow I meet you. Yeah, tomorrow is tomorrow I'll be seeing you. Yeah, tomorrow. Yeah, tomorrow morning. Today night maybe you can try this paper. Okay, we discuss tomorrow. Okay.
Okay.
So I hope you can explore further. Yeah, a lot. So more you explore, more you prepare. So tomorrow I hope you can finish that paper, the August 18 paper, and more than that. So we discuss tomorrow. So yeah, so I stop here for time being. Okay. Any other questions, guys? You have? No questions, Okay, so I stop here.